Hi folks, today I bring you another panel, better saying 3 panels, but all of them use the reference LED driver TM1628. In addition to trying to demonstrate how to bring a panel to life with the TM1628, I also intended to make a small kind of the comparison between the SM1628C and the TM1628. Note that in the pinout they are identical. The initialization command lines too, but there is a detail that makes all the difference between them, and I will highlight it later after the presentation of the TM1628 and the 3 panels themselves. It supports 12 segments in the 6 grid or 11 segments in the 7 grids. The recommended display are common cathode LED. There seems to be some confusion in datasheet regarding its keys capacity. In the diagram, it shows 2 by 8, which result in the 16 keys, but in the schematic there are 20 keys. It is not important because we don't use usual that many keys, and the correct number of the keys supported can always be verified. I'm demonstrating with these 3 panels to highlight their versatilities for designers. Each one uses different connections for digits, and the order of the segments is completely different in the 3 models. So don't get discouraged if your panel still presents some difficulties in its use. With a little patience, it is always possible to bring it back to life. I propose to show a panel that has a broken connector area on the PCB, a difficulty that has overcome by connecting the 3 pins direct to the driver pins. I don't afraid of do it because, as you know, I always let a resistor in serial in each pins of the communications present at breadboard to avoid any wrong connection which can deteriorate Arduino. When dealing with a panel of this type, it always involves identifying the pins one by one and creating the code from there, or proceeding to send the code testing the bits that light up the segments. One way or another allows you to achieve results. The connections I have done to each panel is 3 pins for the communication. In this case is the data in, clock, and the strobe. Because the power source of all the panels and the Arduino is the same, the reference is already created, okay? The GND is the same in each element of this setup, okay? Although the control drivers has the same on all 3 panels, we repeat their presentation for the demonstration of each panel, as only 3 small examples of what can be found in the old DVD players which use the TM1628. We have our IC, the reading codes for the panel buttons, the front and rear views of the panel, the conductors used to connect the panel to the Arduino, the relationship between the 2 bytes and the register map for each digit. Finally, the filling of the table to create the hexadecimal symbols from the 0 to F. We have our IC, the reading codes for the panel buttons, the front and rear views of the panel, the conductors used to connect the panel to the Arduino, the relationship between the 2 bytes and the register map for each digit. Finally, the filling of the table to create the hexadecimal symbols from the 0 to F. And we repeat to the last panel. We have the IC present in the panel, and this IC have the wires connected direct to the pin 2, 3 and 4. After you have the codes of the buttons present in the panel, in this case is 5 buttons. After we have the front and the back side of the panel. The relation between the position of the segments in each digit, and final we have the table of the 16 by 2 to draw all the hexadecimal symbols in each digit. These three panels have different connections between the display and the TM1628 pins. This is quite visible in the register filling for each digit. To draw the correct segments for each digit, it was necessary to send a burst of the 14 bytes sequence to proceed with the identification of all segments in use in each panel. Only after that identification has it possible to create our 16 by 2 matrix. In this case, 3 matrices are created to draw the hexadecimal symbols from 0 to F in each panel. As I said before, although they are identical in terms of the pins and digit segments capacity, there is a big difference in the use of the SM1628 and the TM1628. And now I draw your attention to this. As you can see in the SM1628, the equal segments in each digit are controlled by the column, while in the TM1628, total of the digit is controlled by the row. This requires attention to the code to be used in the matrix. Do not confuse this with the situation of this research to swapping common anode display for the cathode display. These are different situations because in one they use the segments pin correct, while in the other they use the segments as grids to get more digits. These will not be advantageous here because we have 6 digits or a maximum of 7 digits.